Thanks very much. I came all the way from 5 miles away from my office, so really arduous trip. Although actually on LBJ, everything is an arduous trip. Yeah, I have the pleasure of speaking a little bit about a topic that's very near and dear to my heart, which is integrated design. And believe me, nothing lasts longer than bad design, and there is an awful lot of it that we all have to live with. So when you have the opportunity to do something new, it is a gift, and we often squander that. So I'm going to talk a little bit about that today, and I'm going to focus on buildings, and buildings are, a very large portion of our energy portfolio. Well over 70% of all electricity we use in the United States goes to buildings and all the functions that we have in them, just like we're doing here today. So I heard it mentioned this morning. The negawatt is I'm going to jump to the conclusion, but the negawatt is really the solution to a lot of the issues that we're having, and it's a measure of energy efficiency. It was a typographical error of the word megawatt. I think from a Colorado utility report, Amory Levins found it back a couple decades ago, and he said, that describes exactly what I've been trying to explain to people. So solar and wind are certainly the sexy cover girl and cover boy issues, but believe me, nothing saves energy in a more financially and environmentally beneficial method than efficiency. And the problem is the spokesperson for efficiency is kind of like the nerdy guy over up on the slide. It just is hard to get people excited about efficiency. I get excited about efficiency, but I think I'm like the 1% or something. And I'm probably among a lot of friends here today who also get excited about efficiency. It really is the less expensive way to go is to design out the watt in the first place. And it can be done in retrofit as well. It's much easier in new construction. So I want to talk a second about, I thought this was kind of interesting. I read this a little while ago. Somebody talked about, energy sources. And there's really two different types of energy sources we have. We've been relying for centuries on fuel as a source. But if you think about what's coming online now, the renewables and the improvements in efficiency, they're really technologies. And technology generally improves in performance and falls in price over time. I've got a curve up there of the price of PCs, but we could look at phones, we could look at just about anything. And in fact, the solar curve looks similar to that too. They all look very similar. As volume ramps up and more people get there and more people start selling them and more people start doing research, the price just plummets and the technology improves. Whereas fuel, that doesn't occur. The technology has enabled us to access additional fuel sources, but at greater cost. And so supply and demand is going to work a beating on that, whereas the technology is just going to continue. So I think it's really kind of exciting. I was building solar energy projects when I was in high school, and it's very exciting for me. These days that we're living in, it really feels like it's finally transitioning. I mean, we'll look back a decade from now and think we were living in the time where we finally started realizing that the transition is going to occur. So let me talk about one other piece, technology and technique. And technology is the stuff that I've been talking about, right? They get developed and they get mass-produced and the price comes down. But technique is how, or the process is how we go about implementing those. And I'll just show you, here's my little short motion picture of what I think the progress is in these. Technology moves like the rabbit, the hare, and technique moves like the tortoise. We hold ourselves back a lot of times with our processes and our procedures and the way we go about things. So I want to talk about integrated design, which is a way, I'm used to doing it on buildings, but it's a way to do on a number of things. The typical linear design process, and apologies to the better architects in the house, oftentimes when a building is built, the architect draws up a beautiful, it feels like this, he drops a beautiful design and then tells everyone else to make it work. So you got to cram the ductwork in ceilings that are too low, and you got a terrible solar load from a west-facing beautiful window wall lobby, and we've all of us that are engineers have had to deal with a design that just didn't consider what part of the world it was in, where the sun was at during the day, and a number of other factors. And oftentimes in these projects, things get spiral out of control and over budget, and then the dreaded value engineering occurs at the end. But there is a better way, and it's integrated design. And if you think about the building envelope and all the things that need to be considered, if the architect or whoever's leading the project gets the interested parties involved and starts considering all these things, then the design will be much better. Because let me tell you, value engineering is neither, to steal a quote from Amory Lovins. Things get cut toward the end of the project, people don't consider how they interrelated with other things, and it really is no value to anyone. The value occurs in doing smart design from the start. And so I tried to think about how I would convey this, and I thought about kind of some loops that would then cascade. In the concept part, the conceptual part of the design is where really the magic happens. And if you get enough of the right people in there, then you can understand, no one person knows everything, but if you listen to a lot of smart people, you can know a lot of stuff. And you can get kind of a concept of a design, and then you can break out and go work on the detail a little bit. And you come back and you refine that again, and you break out and you work on the detail. By the time it goes to construction drawings, you've got a solid design that's likely to have very few change notices and actually speed the back-end construction part of the process. So it doesn't really cost you any extra time. And this chart that I found just explains it beautifully. The earlier you start, the less effort and the lower the cost, and the better the cost effectiveness is of any of these tools. When you wait till the building is there and you say, I really don't care for the way this is, it takes a lot of time and effort and money to go fix that. So I'm going to share with you two personal examples of integration that I've been involved with. Back in the early 90s, I designed my own passive active solar house. It's right in Fairview, Texas, for those of you from the area, right between Allen and McKinney up Highway 75. I was the architect, engineer, finance department, interior designer, so there weren't a lot of debates to have with other people, but I really studied a lot of these things and hired a small local builder. I have plenty of stories about trying to find a builder, but I finally found a guy who got it. And we went out to suppliers, and we really spent way more time than he wanted to. He was a builder. He was ready to get his hammer and go. That's just in their nature. But we talked a lot about, the systems and how they interrelated. And there's also in building, there's quality, cost, schedule, pick two. I told him, I said, you're going to have to tamp down your rush to go because I want the quality and I want the price, and the schedule will take care of itself. And so we took the time and did the project in a more thoughtful process. And this was before the internet, so it took a lot of time. You had to write for catalogs and wait for them to come in and call people on the phone. Remember those days? So let me show you, there's a little loop here that shows how a lot of this stuff goes together. If you think about, as you're doing the square footage and how the rooms relate to each other and where the windows are and how the overhangs, if you do these things right, and in my house, we ended up with the right orientation with respect to the sun, put the windows, quality windows in the right place with the right overhangs on the right walls, high levels insulation, air tightness, nice reflective metal roof for here in Texas. That led to a significantly reduced heating and cooling load. So some of the money that I didn't have to spend on a multi-ton air conditioning unit and that I was spending on a smaller one, I could get a much more efficient air conditioning unit. And I could also then go with a ground source heat pump. So I spent money on other things, but I saved some of that money back, and then I invested a little bit of it to become more efficient. And all of those combined for better comfort at lower energy use and cost. And I know if we had a lot of time for questions, somebody would eventually say, how much did the house cost? I'll tell you that the payback from a cash flow standpoint was 1 month. In my first month in the house, I saved more in electricity and water bills than I paid in the principal and interest on the extra that I spent on the home. So it was really cash positive from the day I moved in. And then once the mortgage is paid off, all the savings are mine. So the results of the house, I have energy costs about 1/3 of my neighbors. This house is 18 and a half years old now, and it still beats almost everything that's being built today. That's the sad part of the story. My water costs are about 1/6 of my neighbors. I saw some stats in an earlier presentation, 80 to 100 gallons per person per day residential. We use about 30 gallons per person per day residential. And Dallas is much higher than that national average number. I have very low maintenance costs. We thought about maintenance issues. We won the 1996 National Association of Home Builders Energy Value Housing Award for innovative design. My builder applied. I didn't even know he did that. The thing was on budget. We didn't have any value engineering required, and the builder and I are actually still friends to this day. So that just tells you, if any of you have ever built a house, you know how rare that can be. So every year we're on the national tour of solar homes. I've toured now about 1,700 people through the house over the years. And I brought some of our TI vice presidents up there one year for a tour. And that led to my case study number 2. But I'm going to tell you a little bit of bonus. All the things we did in the house were almost all efficiency. I had solar water heating from the start, but I was not generating any electricity. I was just minimizing my use. So then what that allowed was a few years ago when solar electric prices just plummeted, I was able to put in 2012, late 2012, I put a PV system up on the roof. I put 3.3 kilowatts, which covers about 2/3 of my annual electric consumption. Several months of the year, I'm net positive. I could have put a 5 kW system on there and been net zero, but back to process and policy and technique, my utility charges me a $5 penalty if I don't buy at least 100 kilowatt hours from them a month, and they pay me zero for any excess I send back. So I'm basically penalized for being too efficient and for generating my own power. So the technologies are there. We just haven't caught up with how to use them yet. And our next speaker, I was excited when I heard Jim Kale was speaking right after me because he's working on integrating PV into the grid and all those kind of things. So this is just perfect, and I'm sure he's working on technology, but he knows the challenges are in the implementation of how we get this out into the utility industry. So case number 2, semiconductor manufacturing. So TI, Texas Instruments, many of you probably thought of the calculator, right? That's about 3% of our business, the only thing we sell that a consumer can go and buy. The other 97% is we make chips. Lots and lots and lots of chips. Tens of billions with a B a year. You're probably wearing, there's some in your car. There are TI chips. If you got an iPad, there's about 10, 12 TI chips in a single iPad. They are all over. The projector's got them. We sell to everybody who makes stuff that you buy, and our chips are in there. So we make a lot of these chips. And to do these, we use very large clean rooms. And so here's an example of a big clean facility where we call them fabs because we fabricate chips on large silicon wafers. So the picture there is a guy holding a 300 millimeter, 12-inch diameter wafer, or girl. He's in a smock, or she's in a smock. I don't know what it is. But on each of these wafers, we pattern and basically print and build up chips, 20, 30 layers of processing. And then they slice them and dice them and put them in the little packages and send them. Well, these rooms are extremely clean. I've got an example on the side there of the thickness of your hair is like 80,000 nanometers. Your DNA is 2 nanometers. We're down processing in the 30, 40 nanometer range. So cleanliness is important, tight temperature, tight humidity for these kind of processes to be successful. So what does that do? Well, it gives us an opportunity, a challenge, but an opportunity. We have all these tight requirements. We have a lot of exhaust, 2 Macy's Kermit balloons per second of exhaust. I can say the CFM in here, a lot of people will get it, but everybody likes the picture 2 balloons shooting out of the building every second. The recirc air is 22 Goodyear blimps a minute to go through the HEPA filters. 22 Goodyear blimps every minute. So what happens is if you just said, build me this to code, I need it now, it would use about 10,000 houses worth of power and about 6,000 houses worth of water, $20 to $25 million in electric bills a year. This is an opportunity. 10% savings on that is pretty good. 20%, even better. 30%, now we're talking. My one fault was I didn't ask for a percentage of the savings for myself. So just make a note of that. Lesson learned. So what do we do process-wise? Well, normally we build a lot of factories. I've been doing these for 30 some odd years. For a while, we would just take the last design, we'd think of it things that could be tweaked, we'd build the next one, so on and so forth. Well, to really do it differently, we had to do differently on the process. We started about a year, we heard rumors that maybe we'd be looking for another factory site. So we got a couple of ad hoc teams together and started writing white papers, technical papers on things we could do differently. And we convinced ourselves that there were a lot of opportunities. And the papers were peer reviewed, and we started trying to figure out how to convince our management. Well, the house tour was really the thing, because one of our VPs said, we need to bring our senior vice president of manufacturing up to your house, because when people see something, it makes a bigger impact. So we went up, and he's an engineer by trade, and he was asking all about the low-E windows, and we were having a great old time. And then I showed him my utility bills, and he picked it up, and he said, oh my gosh, this is all electric house, this is it? Yeah. He said, well, I wish I'd come here before I built my house, but that's too late. He said, I have two questions for you. I see integrated design in a house. Does this scale up to a factory? I said, yeah, it's fully scalable. Degree of difficulty goes up, like, you know, a dive in the Olympics. I'm doing triple backflip with a half twist gainer. But it can be done. You just got to herd all the cats. And he said, all right, what do you need from me to make this happen? Well, after my jaw, which had unhinged, came back up off the floor, I said, I've been talking to this guy, Amory Levins, out at Rocky Mountain Institute. I want to bring these guys in for a 3-day design charrette. We're gonna get about 30 TIers, 10 or 12 of them. We're going to design the factory the way it should be. And he said, how much would that cost? I told him, he said, let's do it. And I said, I also need you to support this, because if you say you want it, it's going to get a lot more traction than just me. And he said, you got it. So we held that workshop. It was December of 2003, first week of December. My 3 favorite days in my almost 32 years at TI. The energy level in that room and the excitement was just phenomenal. And we really, in 3 days, came out of there with the roadmap for a super factory. And then to implement it, the next part was my boss came up with my Sustainable Development Manager title. He said, look, you're going to be on the project, but if I give you the chiller system or the air conditioning system, you're going to get tunnel visioned into that. He said, you're going to be still reporting to me, assigned to the project, and you got to integrate you got to herd all the cats. And that was really, really helpful, because oftentimes in a project, everybody gets their little section, right? And they start working on that, and they forget to think about the building is the goal, not just your system. The project manager did a great job. I mean, every meeting at a TI project starts with, you know, slides, safety is always first, cost is second, schedule's third. But on the front page, sustainability was up there. And this was 2003, 2004. LEED was still pretty new. Not many people knew what it was, but our project manager had it on the front page. So if they didn't know, they at least would sometimes ask after the meeting, what is this LEED thing, and what do I need to be doing? So that helped get everybody aligned from the start. Well, right about the time we got going, the same VP who toured my house said, oh, by the way, project team, I want this factory to be 30% less in capital costs, non-inflation adjusted, from the one you built just down the road less than 10 years ago. First response, well, there goes the end of the green stuff, right? Because everybody knows LEED buildings cost more than non-LEED buildings. We can't afford to do that. Myth busted. It was the best thing that could have happened. We could no longer just kind of copy the previous factory and meet the 30% capital cost reduction. We had to blow that up, just like we did for all our energy system analysis. So the same process we used in the charrette, we took out capital cost, and we were able to integrate all of the sustainable design and energy efficiency features right there from the start. This was a quote Amory said in the charrette, and I found it just happened over and over again. You know you're on the right track when your solution for one problem accidentally solves several others. And we kept finding that to be the reality. So here's a little integrated design example, chillers and boilers. So in these large facilities, two of the big energy users are chillers to make cold water that pipes around and does its function, and then boilers to make hot water to pipe around and do its function. So in these fabs, the chilled water, the primary function is dehumidifying that incoming air, right? We throw those 2 Kermit balloons out, well, we got to drag 2 more in, and it may be 100 degrees and 80% relative humidity. We need to dehumidify a lot of air. And so the chilled water is usually 40 to 42 degrees to accomplish that. Well then, ironically, you can't introduce it that cold because you'll get cold spots in the fab. So we use hot water to reheat it a little bit after we get the dew point. Hot water is also used in the winter, obviously, for cold air. Then the factories have a lot of waste heat. We use a lot of that chilled water. We usually raise the temperature so we don't get condensation. So we pay to cool a lot of chilled water. We use some of it for humidification, and then we reheat the rest. Real thermal geniuses, but everybody does it that way, or did it that way. So here's what we ended up doing. We said we need a split chiller plant. We need a smaller set of chillers at 40 or 42 degrees to do dehumidification, but then a larger set running at 54, which can be much more efficient to do all the sensible cooling. What that did for our heating side was we have compressors, so we took the waste heat off those, but we put heat recovery bundles on all the chillers. And now we can gather all that waste heat, which is constant year-round. It's waste heat from the manufacturing tools. We could gather all that. We have boilers as a backup. They have not run in the last 2 winters. Once we got enough tools in there, we have had no boilers running. We only installed 1 in a backup instead of 6 that we would have done. So we saved the capital cost of those. We saved the space in the mechanical room that we didn't need for those. And when you do it in the design, all those other things can cascade through for savings. So the chillers are optimized for their function. The waste heat's recovered. The boilers really went away, and they're natural gas. They're our number one on-site emission source. So conference theme, clean air through energy efficiency, was accomplished when we got rid of boilers. The capital cost was neutral or favorable. The operating cost is permanently lowered, and the upstream emissions from our electric purchases are permanently lowered as well. The office efficiency, no surprise, looks a lot like my house. Pay attention to the windows and the orientation and natural daylighting and all those things. We did more integration on the site. We had a 92-acre site up there that had been a wheat farm, and so not a native sprig of grass or anything left on there. We renaturalized most of it, so we only have to mow 1 or 2 times a year. We have no irrigation on the vast majority of that property. When we did need irrigation, we did a 3 million gallon rainwater collection pond at the low end of the site. We pumped that back for what little irrigation we do around the building foundation and the plantings. And we even used a little windmill with an air compressor to aerate the pond to keep it from stagnating. Just a few more photos of the facility there. So we invested, I went at the end and I added up, we got some savings from no boilers, but we spent a little more on this. We ended up with about 1%, less than 1% of the project cost. This is about $1.5 million on a $320 million building. And a lot of those we probably would have done anyway for efficiency. Overall, we actually exceeded the 30% project cost rate. So I can say I built a LEED Gold building for 30% less than a very similar building 6 miles away less than 10 years before. We saved about $1 million as the thing was ramping, and it's still ramping, by the way. It's about 60% full of the tools that go in there cost multi-billions of dollars, so they don't buy them all at once. It's about 60% full. It's the number one fab at TI, the largest factory at TI. It's still growing. We're saving now about 3-point-something million a year in utilities every year, and that'll ramp up easily past 4. We slashed energy, water, and on-site emissions. It was the first LEED Gold certified semiconductor fab in the world. Like I heard AT&T talk about this morning, sharing with people. We shared heavily with other semiconductor companies. The president of Samsung flew over to visit. TSMC from Taiwan came over. A lot of those guys are doing green factories. And somebody asked me one time, why are you sharing all this? Well, 1, it's for our combined good. But 2, we all buy manufacturing tools from the same 8 or 10, 12 suppliers. They use about 40% of our energy when we install them. So we all begin to work together to help drive our tool suppliers' energy efficiency higher, which benefits us all. And if they catch up to what we did several years ago, that's fine, because hopefully I'm one more step ahead of them on the next building. So here's our trends at TI. After we built the new buildings, we bought a lot of factories after the 2009 downturn. We bought 5 old existing factories. I wish I could have built another new one, but now we have to go get those up to speed. But we've been pretty successful. I'm going to show you a couple trends. The first one is the wafers out. So everything's indexed to 1.0 on the bottom. At the end of 2013, we had just about doubled wafers out from 2005 to 2013. The water that we use is only up 28%. The space that we have, you can see it climb as we bought factories, and then we shut down 2 older, smaller, inefficient factories, is up 13%. Energy consumption in that time is up 7%. When I finished this for 2014, sometime in about the second quarter, we cut our energy intensity exactly in half from 2005. Now, this morning I saw the chart. The United States did that in about 38 years for our energy per GDP. We did it in 8.5 years, the energy that it takes for us to manufacture a typical semiconductor chip. So in summary, the US has sliced energy efficiency in half since about 1975. We did it in 8.5 years. Lately, natural gas has been getting a lot of publicity. It's displacing coal on the grid, but in 2012, energy efficiency displaced twice as much coal as natural gas did. How much publicity did it get? Like, none. We already have the technology available. Remember, the rabbit is running very fast. It's really, and anything we don't, like batteries and what you're about to hear about on the grid, is catching up quickly. So where we're falling short really is in our processes and our policy. We're not taking full advantage of everything that we could. So here's some links. They said these will be on the website. You can go tour my house online. You can look at the factory online, or citizenship report with all these index figures are on there. And there was a great Forbes article about it 2 years ago about the Parkland Hospital, using integrated design down there really reflected a lot of the things that I've talked about here. So you'll enjoy that. And I don't know if we have time for questions, or you want to hold them until the end?
Let's hold till the end if you don't
We're going to hold the questions till the end. And so technology is flying away. And so Dr. Jim Kale is here from the National Renewable Energy Lab. And let me make sure I get the title right because it has a key word in there. Good job. Distributed Energy Systems Integration Group. Integration being the key word there. So he is working on, all this PV and the wind and everything that we're trying to bring online. How does that interact with our grid? And I'll tell you what, utilities are very slow to change. So his work is cut out for him probably in the technical side, but I think he will probably agree that the next piece beyond the technical is the real challenge. So please welcome Dr. Jim Kale